Hello and welcome to Ohmazing Physics. The principal objective of this video is to introduce students to microprocessor-based systems and the roles that microprocessors has in it. Additionally, it also explains various components required to build a microprocessor system and the working of generalized microprocessor unit. Well, then what is a microprocessor-based system? Don't worry, we shall get fair idea about this on completion of this video. As a part of introduction to the microprocessor-based system, I would like to share philosophy behind this microprocessor-based systems. Let us consider analogy of a small organization. It consists of managing body, manager and his subordinates, incoming unit and dispatch unit. Here the managing body gives step-by-step procedure to solve the problem or to implement the task. Manager interprets the step-by-step procedures and instructions given by the managing body and executes those with the help of his subordinates. The manager and his subordinates who belong to processing unit can request for raw material to stores. If raw material is not available in stores, processing unit can request for raw material to incoming unit. After processing the raw material, processing unit can either dispatch product or keep it in stores. So looking at this environment, somebody engaged in thoughts. Can we design such an organization without any involvement of human beings? Can we replace human being with some electronic devices which can mimic the operations executed by human beings? And thus in this way the idea of microprocessor-based system was born and design process was started. They replaced raw material by data and instructions by code with ones and zeros. Over the period of design process, designers first came up with an integrated circuit which has an ability to mimic the processes executed by the processing unit, as it is a heart of organization and has an ability to process input as per the instructions of managing body. It was named central processing unit or simply processor. To get the data as an input and to give information to the users, the designer team came up with the input and output devices, which is in another integrated circuit. This integrated circuit accepts data as an input and process it according to instruction code to generate an information. Therefore, with the use of input device, processing unit can get the input, and after processing the input, processor will give the information to the user with the help of output device. The integrated circuit was also designed, which has an ability to store the data, instruction code and information. As it stores data, instruction code, and information, it was called memory. The system with central processing unit, input device, output device, and memory can be visualized as shown here. The system designed here is very small in physical size as compared to the organization with a human being. The processor is an integrated circuit in a very small size, and hence more appropriate name for it was suggested as a microprocessor. The system as a whole was then referred to as microprocessor-based system. A microprocessor, also known as a central processing unit, is an electronic device that is designed to execute computer programs and perform arithmetic, logic, and input-output operations. It is the primary component of a computer system and is responsible for executing instructions and controlling the flow of data within the system. The microprocessor is a clock-driven semiconductor device consisting of electronic logic circuits manufactured by using either a large-scale integration or very large-scale integration technique. The microprocessor is capable of performing various computing functions and making decisions to change the sequence of program execution. In large computers, a CPU implemented on one or more circuit boards performs these computing functions. The microprocessor is in many ways similar to the CPU, but includes all the logic circuitry, including the control unit, on one chip. The microprocessor can be divided into three segments for the sake of clarity, as shown here. Arithmetic, logic unit. This is the area of the microprocessor where various computing functions are performed on data. The ALU unit performs such arithmetic operations as addition and subtraction, and such logic operations as an OR, an exclusive OR, register array. This area of the microprocessor consists of various registers identified by letters, such as B, C, D, E, H, and L. These registers are primarily used to store data temporarily during the execution of a program and are accessible to the user through instructions. Control unit. The control unit provides the necessary timing and control signals to all the operations in the microcomputer. It controls the flow of data between the microprocessor, memory, and peripherals. Now let's discuss how the microprocessor executes instructions and sends the result to the output port. We know that the microprocessor is the brain of a computer and it is responsible for executing instructions that are stored in the memory. These instructions are executed in a sequence known as the fetch, decode, and execute cycle. Initially, the instructions are stored in the memory in a sequential order. The microprocessor fetches those instructions from the memory, one at a time. The fetched instruction is then decoded to determine what operation needs to be performed. After the instruction is decoded, the microprocessor executes it. The execution may involve performing arithmetic or logical operations, moving data from one location to another, or branching to a different part of the program. During the execution phase, the register stores temporary data that is used in the computation. The arithmetic logic unit performs the computing functions, such as addition, subtraction, multiplication, and division. Once the instruction is executed, the microprocessor checks if there are more instructions to execute. If there are, it goes back to the fetch phase and fetches the next instruction. This process continues until the microprocessor encounters a stop instruction. In conclusion, the microprocessor follows a sequence known as the fetch, decode, and execute cycle. It fetches instructions from the memory, decodes them to determine what operation needs to be performed, and executes them. The register stores temporary data, and the ALU performs the computing functions. Once the execution is complete, the microprocessor sends the result to the output port. As of now, we know that microprocessors form the foundation of modern technology. Here are 5 features that make them so special. 1. Cost effectiveness. Microprocessors are available at low prices, making them an affordable option for a wide range of devices. This results in lower production costs for manufacturers and more affordable prices for consumers. 2. Size and portability. Microprocessors are incredibly small in size, making them easy to incorporate into a variety of devices. This portability allows for the creation of lightweight and compact devices that can be carried around anywhere. 3. Low power consumption. Microprocessors are designed using metal oxide semiconductor technology, which has low power consumption. This means that devices using microprocessors consume less power and have longer battery life. 4. Versatility. Microprocessors are incredibly versatile, as the same chip can be used in a number of applications simply by configuring the software program. This makes it easier and more cost-effective for manufacturers to produce a wide range of devices. 5. Reliability. The failure rate of an IC in microprocessors is very low, making them highly reliable. This means that devices using microprocessors are less likely to break down or malfunction, giving consumers peace of mind. Hence, microprocessors are an incredible invention that have transformed the world of technology. Their cost-effectiveness, small size, low power consumption, versatility, and reliability make them an ideal component for a wide range of devices. So now that we understand how microprocessors have evolved into the core of modern technology, but the terminology associated with them can be confusing. Here are 5 frequently used terms and what they mean. 1. Instruction set. The instruction set is the set of instructions that the microprocessor can understand. These instructions determine what operations the microprocessor can perform. 2. Bandwidth. Bandwidth refers to the number of bits processed in a single instruction. A wider bandwidth allows the microprocessor to process more data at once, which can increase its performance. 3. Clock speed. Clock speed determines the number of operations per second the processor can perform. It is expressed in megahertz or gigahertz, and is also known as clock rate. A higher clock speed generally results in faster processing times. 4. Word length. The word length of a microprocessor depends on the width of the internal data bus, registers, ALU, and other components. An 8-bit microprocessor can process 8-bit data at a time, while a 64-bit microprocessor can process 64-bit data at a time. The word length can affect the performance and capabilities of the microprocessor. 5. Data types. Microprocessors support multiple data type formats, including binary, BCD, ASCII, signed and unsigned numbers. These data types determine how the microprocessor interprets and processes data. Although we now know that microprocessors are complex devices, but understanding the terminology associated with them can help demystify their inner working. We hope this guide has helped you better understand 5 frequently used terms in microprocessors. Overall, the microprocessor is a highly complex and powerful device that plays a critical role in modern computing. Its ability to execute instructions quickly and efficiently has enabled the development of sophisticated computer systems and has revolutionized the way we live and work. Learning how to program a microprocessor can be a fun and rewarding experience. With the right tools and knowledge, you can create your own custom devices and gadgets, and even control the world around you. In the coming videos, we will delve deeper into the world of microprocessors and cover topics like programming, interfacing, and circuit design. Whether you are a hobbyist, student, or professional, there is something here for everyone. Thank you for watching, and subscribe for more exciting content on microprocessors.